Hi, I'm Fiona.
And I'm Meryl.
And our topic for this podcast is wind, global wind patterns, and the Coriolis effect.
Wind. Wind is the movement of air from areas of high pressure to areas of low pressure. So how does wind work? The sun's rays make the temperature of gas at the atmosphere hot at the equator and cool at the poles. The gas at the equator expands because of the heat. The air becomes less dense and rises to the poles. The air then cools down at the poles, becoming denser and travels back to the equator. This continuous cycle causes wind. Atmospheric pressure. Atmospheric pressure is the weight of the column of air above any point on Earth. It is measured using a barometer. Higher pressure is found at polar regions, while air at tropic regions has low pressure. Convection currents. Convection currents are the path of rising and sinking of air. It can cause changes in atmospheric pressure, which causes wind. Coriolis effect. Coriolis effect is the deflection of any object from a straight line path by the rotation of Earth. Gustave Gaspard Coriolis, a French engineer and mathematician in the 19th century, first discovered it. He described it as an object that when moving north or south appeared to be deflected off course to the east. This means that the object would move to the right in the northern hemisphere and left in the southern hemisphere. Coriolis effect occurs because of Earth's eastward rotation. The wind is blowing towards the equator, but because of the rotation, it moves eastward. In Canada and USA, the effect is called prevailing westerlies. These winds in temperate regions circulate clockwise in the northern hemisphere and circulate counterclockwise in the southern hemisphere. Global wind patterns. Convection currents in the atmosphere circulate thermal energy around Earth to evenly heat the world. It transfers energy from high net radiation budget to low radiation budget. This ensures that areas near the equator don't grow too hot while the rest of Earth cools. Trade winds. This is described as warm rising air currents flowing towards poles at high altitudes where air cools down and returns back to the surface. The air moves back to the equator and heats up once again. The air circulates from the North Pole to the equator or the South Pole to the equator. The Coriolis effect causes trade winds to go west. In the northern hemisphere, it blows from northeast and is therefore called northeast trade winds. In the southern hemisphere, it blows from southeast and is called southeast trade winds. Jet stream. Jet streams are a band of air in the troposphere that can be compared to thin ribbons of fast-moving air. The air moves quickly because there is less friction at high altitudes. It can be found at boundaries between polar and temperate zones and temperate and tropical zones. It is where cold air meets hot air. In colder months, the air moves closer to the equator. This happens because cold air has higher pressure. Therefore, it moves to a place of low pressure or a hotter place. There are 2 to 3 jet streams in the northern and southern hemisphere. The winds are weaker in the summer than winter. They are generally thousands of kilometers long, few hundred kilometers wide, and a few kilometers thick. Convection currents are found to form jet streams. These are our photo credits. Here are some sources to help you further understand this topic. In conclusion, wind is the movement of air from high pressure to low pressure areas. Because air circulates this way, it creates a global wind pattern. The Coriolis effect is when an object is deflected from a straight line path because of Earth's rotation. Trade winds are when warm air moves towards the poles where it cools down and sinks toward the surface and the equator where it heats up and circulates once again. Jet streams are a band of fast-moving air in the troposphere where cold air meets hot air. This concludes our podcast on wind, global wind patterns, and the Coriolis effect. Thanks for watching!